I have two examples on how the substrate affects the properties measured from the thin films. Here we have a thin film deposited on a substrate. We wish to calculate the transmission through the film and the substrate. So the procedure is we need the transmittance and reflectance of the first interface, and they can be calculated with the help of the coherent T matrix. Transmittance and reflectance of the second interface can be calculated directly with the help of Fresnel's equations. The substrate can be lossless, but the loss can be included in the incoherent matrix model. And finally, with the use of the transmittance and reflectance of the interfaces, and by possibly taking the loss of the substrate into account, we can calculate the total transmittance through the film and the substrate. Here is a MATLAB model of the thin film on a substrate. So we can calculate the transmittance of the thin film as previously. By knowing the transmittance, we can calculate the transmittance of the film on a substrate as this. And then the calculation proceeds as before. With the thin film model, we calculate the transmission coefficient and transmittance of the first interface. Then from the Fresnel equation of the second interface, we'll get the reflectance. And finally, the total transmittance is calculated with the incoherent matrix model. And let's run this. Here we see the effect of the substrate. The reflections of the substrate interface is reducing the overall transmittance. And let's tune the thickness of the thin film to get the different periodicity. We can also add some loss in a substrate and see that the transmittant spectrum is dropping due to the absorption of the substrate. Second example, we again have a film on a substrate and we want to measure the properties of the film. And our question now is, does it matter from which direction we make the measurement of reflectance and transmittance? So let's take the transmittance of the film first. In the forward direction, the total transmittance is given by the formula including the transmittance of the interfaces and the reflectances. If we make the measurement in reverse direction, we write the equation in a different order. So first we pass the interface 2, then interface 1, loss of the substrate is the same, then reflectance, the second interface, and the first interface, and we'll see that the expressions are exactly the same. So it means that the measurement of transmittance can be done from both sides, and the result is exactly the same. Let's now take a look at the reflectance. Reflectance in the backward direction includes the reflectance of the interface with the film, the second interface, transmittance of the first interface, and the loss of the substrate. And let's write the formula for the reflection from the other interface. Here, the first term is R2, R1, transmittance of the second interface, loss of the substrate. And now we see that the expressions are not the same. So we have some differences. So in general, this means that if either the thin film or the substrate has loss, the reflectance measured from different sides are different. However, it can be shown that on a lossless substrate, and if the thin film is also lossless, these expressions will eventually be the same.